Okay, so we've got a question here. We've got the natural log of x squared plus 5x plus 6 equals 2 plus the natural log of 2x squared plus 7x plus 3. And we want to solve for x. And we want our values of x to be greater than or equal to 0. So what's really important with the natural log, we don't want values of 0 or less than 0 on our inputs for these values. Now these quadratics, they will have values less than 0 or 0 between -0.5 and -3. So we've just got to be careful there. So what can we do to start with to solve for x? Well, first of all, we get the x terms on one side. So we could bring this natural log term over here first of all. So then we'd have the natural log of x squared plus 5x plus 6 minus the natural log of 2x squared plus 7x plus 3, and that equals 2. So we've got all the natural log terms in there. Now we've still got the x terms inside this logarithm, so we need to do something else. So what we could use is a logarithm identity. So we know that if we have, let's do it on here, log of a minus log of b, that is the same as the log of a over b. So we could use that identity for this. So let's put this one in the numerator. So log of x squared plus 5x plus 6 divided by 2x squared plus 7x plus 3. And that's all inside the brackets there. Okay, and then let's set that equal to 2. Okay, well this does look a little bit of a mess. So why don't we try factoring it out and see what we can get to. We might have some calculations we can cancel out. So we've got the natural log. Right, x squared plus 5x plus 6. Let's factor this one out. So now we've got x and x. Now we've got a plus 6 here. So we need factors of that to sum to 5. Well, 3 and 2 will do the job. And we need plus 5, so x plus 3, x plus 2. So that works good for the numerator. Now the denominator, 2x squared plus 7x plus 3. So factoring out this 2x squared, we'll have a 2x term and we'll have a single x term. And then we want to use factors of 3, so 3 and 1. Well, I can see straight away 3 times 2 is 6, and add 1 I'll get 7. So if I put the 3 on this side and plus 1 on this side, they will sum multiplied up to 7x, and 3 ones are 3. So that looks good. And then that equals 2. Okay, well I can see straight away there's a cancellation I can do there. The x plus 3's will cancel out. So that's worked good. So now I've got the natural log of x plus 2 over 2x plus 1. And that equals 2. Okay. Now, but I've still got the x inside the natural logarithm. So what I can do now is use another identity as e to the ln of a. That equals just a. So whatever I've got e to the ln, that will just use the two inverse functions of each other. So if I exponentiate each side, so if I do exponential of that and then exponential of that, I just write that as an e to the 2, then I can then use that rule to just get this on its own. So then I'll have x plus 2 over 2x plus 1 equals e squared. Okay, now let's multiply both sides by 2x plus 1, and then I'll have x plus 2 equals e squared 2x plus 1. Okay, right, let's bring this up here and see if we can finish it off. So first of all, let's expand out the brackets. So I've got x plus 2, that's fine. Then I've got 2x e squared, and then e squared times 1 is just plus e squared. Okay, right, now back to where we was at the beginning, get all the x terms on one side. So now I've got x minus 2x e squared equals e squared, and then bring this 2 over, got minus 2. Okay, right, we can get the x out of this. Let's take the x out. So I've got x 1 minus 2e squared equals e squared minus 2. So you see, factoring that out, multiplying that back out, I should get back what I got, x minus 2x e squared. So that's all good. Now to get x on its own, just divide both sides by 1 minus 2e squared, and then I'll get x equals e squared minus 2 over 1 minus 2e squared. And that is one solution.